Hello, this tutorial will show you how to conduct a one-sample t-test about a population mean or create a confidence interval for a population mean. I will be using the fire drill dataset today. A plant manager claims that the average population evacuation time is 40 seconds. The first thing I need to do is to get my dataset into R Commander. To do this, I'm going to go to Data, Load Dataset, and I will look for my data set. Mine is on my desktop, so I will go to Desktop, Datasets, and find my fire drill dataset. Your dataset may be in Downloads if you just downloaded the file from Canvas. The first step we want to do is graphically examine our data to see if it meets the necessary assumptions for hypothesis testing and confidence intervals. We are going to assume that our data was collected randomly and is representative of our population of interest. We also want the underlying population of interest to be normally distributed, and maybe to check this we would want to look at a histogram or QQ plot. Check out one of our other YouTube videos to see how to create these graphs. Let's start first by looking at a numerical summary. To do this, we go to Statistics, Summaries, Numerical Summaries. We will choose our variable of interest, evacuation time, and then go to the Statistics tab and choose the Standard Error of Mean checkbox. This is our S divided by the square root of n. Once we do that, we'll click OK, and we see our output in the box below. Our numerical summary shows us that n, our sample size, is 50. Our standard error of the mean is about 3.04, and our mean value was 49. Now we can perform our hypothesis test. Before we run our test in R Commander, I would like to point out that by default, R Commander will create a confidence interval in the hypothesis test output, meaning that you can modify the confidence level and focus on that output or perform a complete hypothesis test. To do this, we go to Statistics, Means, one single sample t-test, and we choose our variable, evacuation time. Then we can look at the options available for the alternative hypothesis. Just to clarify, the exclamation equals is notation to mean not equal to. Since we are testing the plant manager's claim that the average evacuation time is 40 seconds, let's do a two-sided hypothesis and choose the first option. Our null hypothesis value, mu, would be 40, so we type in 40. And below that, we see that R asks us to provide a confidence level, which is the 1 minus alpha. 95% confidence level corresponds to a 5% significance level for our hypothesis test. Let's use this and click OK. Now we can return to our output window and see our single sample t-test output. I have a test statistic value of about 2.96 and a p-value of about 4.75%. So at a 5% significance level, I would reject the manager's claim that the average evacuation time is 40 seconds. Notice that the output does also give the alternative hypothesis. In this case, the true mean is not equal to 40. We also have the sample mean listed below and a confidence interval listed in our output from about 42.89 seconds to 55.11 seconds. If we are only interested in generating a two-sided confidence interval estimate for the population mean, but do not have a hypothesis to test, then we could still follow the steps of doing statistics, means, single sample t-test, and then it would be okay to leave that hypothesized value as 0 and focus on just modifying our confidence level, again leaving the two-sided alternative because we want to make a two-sided confidence interval. Make sure our variable is selected and then say we're interested in a 90% confidence level, and we would click OK, and we would get our results below. When looking at a confidence interval, we would ignore the top half up here, this t-test hypothesis, and focus on the confidence interval down here, which goes from about 43.899 to 54.10 seconds, which is a range of possible values for the population mean evacuation time. That is all I have to show you. Have a wonderful week.